Welcome to the podcast of Flying Green, the Zero-Emission Air Race. The introduction of electric airplanes into the aviation industry is a groundbreaking change that is set to replace the traditional fuel-guzzling commercial jet airliners with greener, more convenient aircraft. These flying vehicles are driven by electric motors, which are fueled mainly by lithium-ion batteries or hydrogen fuel cells. In contrast to fossil fuel propulsion, electric systems save on carbon emissions, noise pollution, and operating costs immensely in the long run. As the necessity of climate change prevention emerges as a critical issue on a global scale, the competition of zero-emission airways gained a new momentum, and companies like Hart Aerospace, Airbus, and the evangelists of electric vertical takeoffs and landings, like Joby Aviation and Lilium, gain more traction than ever. Also, NASA is extending the frontiers with its electrified aircraft propulsion initiatives that are assessing solid state battery and advanced hybrid electric propelled systems. Electric airplanes incorporate the use of electric motors as opposed to the use of traditional combustion engines. These motors are powered by energy stored in onboard batteries or hydrogen fuel cells. As an example, the Diamond EDA-40, which is the first certified electric training aircraft in the world, proves how established airplanes can be converted to have an electric propulsion system and become operational in aviation schools. A typical propulsion system consists of energy storage, power electronics, motor controllers, and lightweight airframes. Altogether, these parts form an effective and environmentally sustainable unit as opposed to jet engines. There are some breakthrough technologies that contribute to the development of electric aviation. Number 1. High density batteries. Lithium ion batteries presently in use are effective. However, they are heavy. It is proposed that batteries must achieve the energy density level of 400 to 800 watt hours per kilogram to produce large regional airplanes. There will be solid state and lithium sulfur batteries in the future. Number 2. Hydrogen fuel cells. The project of Airbus Zero-E is actively developing the hydrogen propulsion technique to reach zero in aviation's emissions. Number 3. Aerodynamics and AI-based flight control. Electric aircraft can integrate complex flight control systems to obtain maximum efficiency in power consumption through the combination of aerodynamics and artificial intelligence. Number 4. Distributed and vertical takeoff systems, eVTOLs. Joby Aviation and Lilium are making vertical flight by means of distributed electric propulsion as a part of their urban air mobility ventures designed to be efficient and redundant. Electric aircraft has several important benefits in comparison to conventional jet aircraft. Number 1. Reduced greenhouse gas emissions. Electric propulsion reduces the level of carbon emissions drastically, contributing aviation industry to achieve international climate goals. Number 2. Lower noise pollution. Being much quieter, electric motors are sustainable in an urban setting. Number 3. Lower operational and maintenance costs. It has fewer moving parts in electric motors, which causes it to have a longer lifespan and lower repair costs. Number 4. Improved regional connectivity. The electric planes are meant to be used on the short haul routes, which can serve remote destinations more cheaply. The example of such plane is the ES-30 of the Hart Aerospace. To flight schools and regional operators, these features offer both a cost-saving opportunity and environmental advantages. Electric aviation is threatened by a variety of issues. Number 1. Battery energy density. Aviation fuel is comparable to storing around 22 times more energy per kilogram than the current lithium-ion batteries. This extremely restricts range and payload. Number 2. Aircraft weight. Batteries weigh a lot, limiting long flight and commercial capability. Number 3. Infrastructure readiness. Airports need a big infrastructure for charging or hydrogen refueling, which is absent today. Number 4. Certification and safety. Regulatory bodies must make sure that New propulsion technologies are safe as per the safety norms. Currently, electric aeroplanes can only cover relatively short routes of less than 500 kilometers, so electrification of long haul flights is many decades in the future. Electric aviation has a great potential ahead. NASA's N+3 program and the Europe's Flight Path 2050 are spurring ambitious research ahead to possibly make electrification of larger aircraft possible in the 2030s. Countries such as Norway have committed to ensure electrification of short-haul flights by 2025, with continued investment by the private companies into research and development being in the billions. Nonetheless, ethical facts cannot be neglected as well. Batteries are produced using rare earth minerals like lithium and cobalt that bring about the questions regarding environmental degradation and working conditions of the mining areas. Moreover, the disposal of used batteries at the end of their useful life offers sustainability complications, which ought to be resolved to ensure that aviation becomes green. Ultimately, the future of electric aviation will not only be determined by the technological innovations but also by the wise use of the resources and equitable access to sustainable air transportation. Electric aircrafts are no longer something that exists as a mere dream in the far future, because it is already in the process of becoming a reality. They are presented as an eco-friendlier, quieter, and cleaner way of air travel, which could transform the aviation market. As great as the challenges are, governments, companies, and research institutions are quickly bringing us into a new age of zero-emission aviation. The sound of tomorrow might not be the rumble of jet engines, but the purr of electric motors, and that noise will signify a step forward in progress, not only in aviation, but in the planet.